And today in this video we'll be discussing the second module of object oriented concepts. So in this module we have two parts. First one will be covering up the C++ topics which we had started in the previous module, and then we'll be getting started with the basics of Java, and we'll be moving on to learn about the if loops and for loops. Till that part we'll do, okay, in this module. So if you like this video, hit the like button and don't forget to subscribe to my channel, okay. And let's move on to the first topic, which is objects and arrays. Okay, so what's an object? Object is nothing but the instance of a class. Suppose that a class has the data members as int a and char b, okay. So if you create an object of it, in the object you will have those data values which can be stored in it, okay. And multiple objects can be created from a single class, okay. So if you want to store multiple objects in a single place, what you can do is like how we used to do for int, right? Int a of 5, then 5 spaces will be created wherein you can store the integer values. Similarly we can do for the array also, for the object also. Suppose that the class is employee and these are the data members and these are the functions to get the data and display the data. So two functions, two data members we have, which is name and age, and by using an array we can store these objects. See here, I created an array of objects of employee e of 5. So 5 spaces will be created wherein I can store each object, okay. So this array will have the name and age as an object here. The second and third and fourth objects will be stored in the array, okay. So this is nothing but the array of objects, okay. Namespace is nothing but a scope where you can define a code. See here, suppose that I include a program here. This is the main program and I have included two files, a1.h and a2.h. What do these two files have? This file has class A defined in the in this file, and in a2 also class A is defined. So if I include both of these files, see, the body can be different here but the name of the class is same, okay. So if I include both of these files in my program, at that time if I create an object of class A, at that time the ambiguity arises of which class I am including, the of file a1.h or a2.h. At that time ambiguity arises. I have created two files here which are a1 and a2, and in both of these files I have created a class, okay. Don't worry about the technical issues here which are like stdc out and all. I'll be explaining those in upcoming topics in much detail, so pay attention to what I say. Here I have created class A with data member x and a function void display, okay. Same thing I have done in a2 also, and the same name and the same function. So what happens is, when I include both of these, a1.h and a2.h, and then without using namespace, if I try to create an object of A, it will give me an error. Why? Because this A is of which file, this file or this file, okay. That ambiguity arises. See, if I try to run this program, what will happen? See, A was not declared in this scope, so it's not defined that A is of this class or this class. So to overcome that ambiguity, what we can do is namespace is used. By using namespace, I can define a1.h as namespace a1. So whenever I use a keyword a1, at that time it means I'm using this this file's class A, okay. If I create a namespace a2, that means I'm creating the I'm using the namespace of a2, okay. So by using namespace, whenever I want to create an object, what I can do is I can mention using namespace a1. So at that time the compiler will know I'm using this program, okay. So this class will be executed. Similarly, if I want to if I don't wish to write using namespace, I can do this also. I can write a1 then followed by double colon a object, okay. So if I use a1 and double colon instead of namespace, that also works the same. This one will be executed, okay. So what I can do is I can either mention as a1 then double colon, then what will happen, a1's object will be created of this file, okay. And if I call this function void display, then this one will be printed inside a1, okay. Let's see that. See here, inside a1 is getting printed, okay. Similarly, if I type here a2 double colon a object, at that time this file this object will be created inside a2, okay. So let's run and see the program. See here, inside a2 is getting printed. So instead of typing in this form like a2 double colon, if you want to avoid that, what you can do is specify which namespace you are using. See, namespace is nothing but a space or a block of code with a name, okay. See, this is the block of code and it's having the name a1. So when I use namespace a1, I'm including this block inside my program, okay. So similarly, I have the second namespace here with the name A2 having this block of code. Okay, so when I include any namespace, if I include A1 and I create an object, at that time A1's object will be created and this will be printed. Okay, let's see that. See here, inside A1 is getting printed, and instead of that, if I include A2 using namespace A2, that means this block of code will be included inside A2, and inside A2 should be displayed. See here, inside A2 is getting displayed. Okay, so namespace is nothing but a block of code with a name, and you can use these names for in your program to specify which file you are referring to. Okay, in case if the class names are same, to specify which class you are using of which file, namespace can help in that time. Okay, so while we write the C++ programs, we will be writing using namespace std. So what does std mean? It's a standard file in which we'll have all the operations like cout, cin, for loop, if else and all. Okay, all these things will be included under the namespace std. Okay, so that's why we include using namespace std. Talking about constructors, suppose that I have a class here with the data members A and B. Okay, if I create an object of it, I'll have the in the object it's empty as A and B. That's not initialized initially. So if I want, whenever the object is created, it should initialize some default values. At that time constructor is used. Okay, so let's see the working of constructor. To illustrate the usage of a constructor, I have created this class. In this class we have two data members which are x and y, and two functions which are set value and display. So I'll be giving you an illustration before using a constructor, and then after using a constructor what are the benefits we get. Okay, so see here in this class, to set the values of x and y, see these are private data members. So to set the values of x and y, what I have to do, I have to call the function set value. Okay, how is set value defined? This is set value. It's defined as cout enter the values of x and y, and then the user will be entering x and y, which will be stored in the class add. Okay, they will be stored in the x and y. Okay, and to display the values, it just displays the values of x and y. Okay, the value of x is the particular value of x, and the value of y is the value of y here. Okay, so coming to int main, I have created an object of add. So a is here, and inside a I'll have the data members. This is the class A, and I have the data members x and y. Then I have called the function set value, so the user will be able to see enter the value of x and enter the value of y. So those value will be stored here. Like suppose I enter 5 and 6, then those will be stored here. When I call the function a.display, these two values will be displayed in the screen as 5 and 6. Okay, so let's run and see the program. Here it's asking me to enter the values of x and y. So if I enter 5 and 6, the output will be the value of x is 5 and the value of y is 6. Okay, now suppose that I have to create multiple objects. That means I create a object along with a, means add b, c and d. In this case I have to call the function a.setval, like I have called a.setval, I have to call b.setval, then c.setval, then d.setval. Means how many objects I create, that many times I have to call this function to set the values of x and y. But you see, in case I have to set the values of x and y same for all the objects, means x should be always 1 and y should be always 2 whenever I create an object. So for all these objects the values of x and y should be same. At that time, instead of calling all these functions multiple times, what I can do is I can use a constructor. What does a constructor do? See, whenever I call a function here, at that time the constructor will initialize the values of x and y. Okay, suppose that I made an object of a, and whenever I make this object, at that time initially the constructor will be called. Okay, this is the constructor. It has no return type. It just has the class name and the opening and closing braces. Okay, so what does it do? As I define here, in the outside the class definition, this is the class name followed by double colon and constructor name. Okay, when I define this, I'll have x as 1 and y as 2. I have x as 1 and y as 2. Okay, so what happens is, whenever I create an object a, at that time automatically the values of x and y will be set as 1 and 2, even if I don't call the function add, because it's a default constructor. I don't have to call it, it will automatically set the values of x and y. Okay, now see, I am not using the function setval. I'll clear it, and I'll be just using the display function. Okay, Now see here, in this case the output should be 1 and 2. Okay, see the value of x is 1 and the value of y is 2. See here, by using constructor you can set the values of all the objects. Now suppose I create multiple objects here, a, b, c, d and e. Okay, for that I have to display those values. Now whenever I create all these objects values will be the same as 1 and 2. Okay, so if I use this function here, after creating all these objects, if I display those values, what will be printed? See all the objects have the value of x as 1 and y as 2. Suppose that I added the value of x and y as 3 and 4. At that time if I run the program, the output should be the value of x is 3 and the value of y is 4 for all the objects. Okay, so this is the use of default constructor. If you have to set the values whenever you create an object and constant values, at that time you can use a constructor. Okay, there are three types. First one is default constructor. In default constructor we will have to write the same name as the class name. Okay, so if I have a class add and 3 data members are there, x, y and z. Okay, whenever I create an object, I want the values of x and y to be always 6 and 5. What I can do is I can define the function add. See, this is the void display function. Along with that, if I have to initialize the values, I have to write the function add. It has no return type, not even void. Okay, so I'll write add here. And what's the definition of add? It will be, this is the class name. If you have to define outside the class definition, you will use this class name here followed by double colon and the function name, which is the constructor. Inside this constructor I want x to be 6 and y to be 5, so I can write like this and then close the function. Okay, so by using this, if I create an object in the void main, see here in the void main, if I create an object a, at that time this constructor will be called automatically. What does this constructor do? It will initialize the value of x as 6 and y as 5 in the object a. Okay, see I created object a here and then I didn't call it in constructor, it's default constructor, so it will be initialized as x as 6 and y as 5. If I don't define the constructor, at that time what will happen, x and y will be empty. Okay, so in this case x is 6 and y is 5. When I display it, the output is like display cout x plus y, so x plus y's output will be 11, 5 plus 6. Okay, so this for the default constructor. Coming to the second type, which is parameterized constructor. In case I want the values to be dependent upon the user, in case I don't want all the objects to have the values of x as 3 and y as 4, instead I want some of the values as the user wants. At that time what I can do is I can make a parameterized constructor. In that I'll have the values. See here, for setting those values I will be defining the function add as, this is the parameterized constructor's definition. This is the definition of the parameterized constructor. Let's see it's working. See, initially if I create all these objects here without using any parameters here, at that time all the all the objects values will be 1 and 2. Okay, means whatever I define here as, if I define x as 1 and y as like 5, all the objects will be created with the values of x and y as 1 and 5. Okay, see here, if I run this program, all the values of all the object values of x and y are 1 and 5. Okay, now suppose that I want the value of b to be 9 and 10. Okay, so what I can do is I can write in brackets 9 and 10, and at that time if I call b dot display, all the objects will have the value 1 and 5 except b, which will have 9 and 10. See here, see all the values of x are 1 except for b, and all the values of y are 5 except for b. Here the value are 9 and 10 which the user entered. So what happens here is, when I use these parameters here 9 and 10, the parameterized constructor will be called, which is defined as follows. See here, inside the class definition you have to write int comma int, because you are passing two int values, and then whatever int value I pass in a and b, those will be stored in x and y. Okay, so in our case I had passed a as 9 and b as 10, so that are so those are stored in x and y, which are 9 and 10. So for that particular object, the values of x and y become 9 and 10. Okay, suppose that I create an object a and the class has x and y. Okay, so I want to initialize x as 5 and y as 6 whenever I create an object, or I can edit the values here. The user can edit whatever value the user wants. Okay, so if I write like this 5 comma 6, at that time this will become 5, this will become 6, or else if I write here 7 comma 8, x will become 7, y will become 8 whenever I create an object a. Okay, so when I display it, it will be 5 plus 6, which is 11 here. Okay, have a look at here. Whenever I write this function add a 5 comma 6, the 5 will be stored in x position and 6 will be stored in y position. It's different from the previous one because in the previous one we had defined the values of x and y in the class definition only, so this cannot change at all. Only in the parameterized constructor, when we pass the values, we can change here. Okay, the user can change the values here, while in the previous one it's defined by the programmer, it can't be changed. Okay, the third type is copy constructor. It's nothing but whenever if you want to create a second object, see here, now there is a third type of constructor which is called copy constructor. In this, I'll initially have an object here, and by using those values of object, I'll be copying those values. Okay, suppose that, see, I have created the objects a and b, and after that I am creating an object c. Initially, if I don't pass any values, means default constructor will be called. At that time, the value of c will be having x as 1 and y as 5. The output of c is 1 and y is 5. Okay, now if I use a copy constructor, means I am passing the value of c as whatever be the value of b, that should be copied in c. I am passing the parameter as b. B is an object which is already created, so the values of x and y for b will be copied to the values of x and y in c. Okay, so what happens is when I call the copy constructor, I am passing the value as argument as b, and the value of b dot x will be copied to x, which is of c. Okay, and the value of b dot y will be copied to y, which is of c. So for whichever object I call add function, those values of x and y will be copied by what object I pass here. In our case, the object is c, I am calling for c, so the object being passed is b, so 9 and 10 will be passed in this place. 9 and 10 will be passed for b as x and y, and those will be copied in the place of c, c's x and c's y. Okay, so let's run and see the program. What will be the values of x and y values of c? See here, the values of x and y are, for c also it's 9 and 10 because it's copied value of b. Okay, now if I added the value of b here like 15, at that time the value will be reflected back in c. First, the object b will be created with the values 9 and 15, and those values of 9 and 15 will be copied to c. Okay, so it's nothing but the an object is being copied as same to the new object. Okay, see here, it's changed as 9 and 15 for both b and c. Okay, so that's how copy constructor works. I've created an object a which is having the values of x as 5 and y as 6. Okay, now if I want to create an object b with the same values of x and y which I have created in a, I can copy these values of a in b by using a copy constructor. In that, I'll pass on the whole object of a while creating b. Okay, so b of a means a will be passed with the values 5 and 6. See here, this is the definition. A will be passed here and stored in p. Okay, you have to use ampersand if you are defining copy constructor. Then what is p here? P is nothing but a is passed, so p will have x as x value as 5 and y value as 6. Okay, now I have called the function for b, so this is the b's x and b's y. So what will be in b's x? P dot x. What is p dot x? 5. 5 will be stored in b's x and 6 will be stored in b's y. Okay, so the if you are creating a new object b and you have an object a here, these values will be copied in the respective positions. Okay, so that's the use of copy constructor. Destructor is nothing but a function, means whenever you create an object here, suppose that you created an object between this scope a, obj. Okay, so an object is created. Now this object can be accessed between this block only, it can't be accessed outside the block or before the block. Okay, so when this scope gets over of this object, at that time the object should be destroyed. So for that, for the freeing of the memory, we have to destroy the object. So for that, a destructor is used. Okay, it's called automatically, but if you want to see how it works, you can define a constructor as cout constructor called, and in the destructor you have to use this sign here along with the class name, then cout destructor called. This is just for seeing when the constructor is called and when the destructor is called. Okay, see here, see if you create an object here, at that time a constructor will be called for this object. Then if you create an object, a second constructor will be called. Then after this scope gets over of object 2, this should be destroyed, so a destructor is called. And after this scope gets over of this object, at this point the destructor is called for object this one. Okay, let's discuss how the destructor works. Suppose that I have a class A, and in this class I have the variable x as a data member, and in public I have two functions, which is a constructor and destructor. Okay, I can create a default constructor also, but I have created a parameterized constructor so that I can know which object I am calling for construction and destruction. Okay, now see here, inside the parameterized constructor I have int a, that value of a will be passed to x. X is the data member of a. So whatever value I pass here while creating the object, that will be stored in that the data member of that object x. Okay, so here is the int main. I created an a object 1. I passed the value 1. So what happens? 1 will be passed while creation of this object, and it will be passed in int a, that will be stored in x. So object 1's x value is 1. Okay, so object 1 has the x value as 1. Next, inside this block I created object 2, that I passed 2, so x value of object 2 is 2. Similarly, x value of object 3 is 3. Okay, now what happens? This object can be accessed from where? This can be accessed within this block, opening braces and closing braces. Okay, that's the scope of this object. You need to know scope very well to understand constructor and destructor. Okay, the scope of object A is in between this parenthesis and this parenthesis. Okay, similarly the scope of this object is in between this one and this one, and the scope of this object is in between this one and this one. So what happens when the scope gets over? When the scope gets over, this object is not required, it should be destroyed. So this scope gets over when when the line crosses this point. After this point, the destructor for this object should be called. Okay, so whenever the program crosses this line, the destructor is called. See here, initially I will explain you from beginning. Whenever I create this object, at that time the constructor will be called here, x will be initialized as 1, and then this statement will be printed. Constructor is called for the object x. Whatever value I pass here, that will be displayed. Means I passed here 1, so it's displayed as constructor called for object 1. Similarly, then I will create object 2, it will be printed constructor called for object 2. Then object 3 will be passed, constructor called for object 3. While destroying the object, at that time the last constructor, which was the last object created, will be destroyed first. You can consider it as a building here. See here, when you are creating an building here, first you will call the constructor for object 1, then you will create another object 2, then you will create another object 3, like that you will keep on building. Okay, but when it comes to destroy the building, you will destroy from the top. First you will destroy 4, so the destructor for the last created object will be called first, then this one, and then this one. Okay, so that's the same thing which is happening here. Object 3 scope gets over first, so that will be called destructor call for object 3, which is the function here. Whenever scope of the object gets over, this will be called, which will print out a destructor call for the object x. What will be the value of x of that object, that will be called as destructor call for object 3. Then whose scope gets over next? The scope of object 2, because it's within this parenthesis. When this gets over here, at that time this will be called destructor call for object 2. Then at last object 1 will be destroyed after the remaining blocks are getting over. Okay, at last destructor called for object 1 will be executed. Okay, so constructor is for constructing the object with either default values or the values which user wants, or if you want to copy the values of another object into the newly created object, at that time you will use a copy constructor. And when you have to free up the memory space after the object is used, at that time you will call the destructor. Okay, for freeing up the memory used. Okay, Nested class is nothing but a class definition inside a class. See here, class A is defined and here you have public, and inside the public our new class definition is found. So this is nothing but a class inside a class which is called nested class. Okay, if you have to define this function outside the class, at that time you have to write the return type of the function which is void, and the class name which is outer class first, followed by double colon, and the inner class which is B, then double colon and the function name. Okay, this is another class where the class nest is defined, and inside the public function class display is defined. Okay, so this is the class display which has a private member which is S, and two functions void sum and void show. Okay, so this is a class inside the class nest, and if I want to create an object of display, at that time what's the syntax? The syntax will be the outer class name followed by double colon, then the inner class name and object name. So nest, outer class, display, inner class, and object name X. So it will create an object X of the type display inside the nested class. Okay, since display class has two functions, void sum and void show, to access these functions we can access directly. If you have created an object X of type display, at that time X dot sum will give the result of the sum, and X dot show will give the result of void show. Okay, so that's a normal access, but just the creation is, first you have to mention the outer class for the creation of object, as well as the function definition outside the class. Okay, first outer class, then inner class, just remember that. Is not like any other programs like Python, C or C++, because in Java there are many things like JDK, JRE, Java Virtual Machine, and Java In-Time Compiler. Okay, so let's discuss each of these. So to understand Java, how it is made, means what is the internal working of Java, you need to understand the JDK. JDK is the toolkit which you download when you install Java, right? At that time you install JDK. What does JDK have? It has all the tools needed for writing the program, debugging it, and executing the program. Okay, so inside the JDK we have many subparts, which are, first one is JRE. JRE means Java Runtime Environment. It's just used for the execution purpose, means when you download Eclipse, at that time you can see the code where you can write at that time. So that is nothing but the Java Runtime Environment. Here you can write the code and execute it. So only if you want to execute the code, just download JRE, no need to download JDK. But if you want to write the code and debug it as well, then you have to download JDK also. Okay, because it has some debugging tools. Then in JRE you have two things. First one is for compilation purpose, second is for execution purpose. Coming to compilation purpose, if you have noticed, whenever you write the code in Java, at that time only the compilation happens. You need not compile the whole program as you do in C++ at the end of the program. You just have to run the program directly, because whenever you write a line of code, at that time the translation happens from the Java program to the machine level language, so the compilation happens in time. Okay, so that's a great feature of Java which saves a lot of time. And coming to Java Virtual Machine, it's a concept introduced by the Java producers to convert the Java program into bytecode. Now what's a bytecode? Listen very carefully, it's very important point from the exam point of view. So bytecode is nothing but a set of optimized instructions by using which the large Java program can be reduced to a smaller set of codes which can be executed very fast. Okay, and the extension of bytecode is dot class. Okay, so it has a dot class extension and it can be run on any machine. By using JVM you can run the same code in Mac OS, Linux, or Microsoft, or any other platforms. Okay, so that's the advantage of JVM. The Java code becomes platform independent when it's converted to bytecode. Okay, this topic has been repeatedly asked in exams, which is Java buzzwords. What is Java buzzwords? See, these are the 11 words which you need to know to understand what's the working of Java. Okay, first one is, many of them are self-explanatory, but I'll be giving a brief information about each of these. Okay, first one is simple, means it does not have that much syntax as C and C++ has, so it's a simple program. And secure means it uses the concept of object and classes, so the data is secure. It's portable because the same Java code can be run on many other platforms under the same Java virtual machine. Okay, so you can run the same code on Mac OS, Linux, or Microsoft, or any other operating system. Okay, The fourth one is it's object oriented, so all the concepts like polymorphism, abstraction, encapsulation, inheritance, all those apply on the Java codes. Okay, and the fifth one is robust, means it manages the memory very efficiently, and it has exceptional handling as well, means whenever error happens, the whole program does not stop execution, but the exception is handled very efficiently. Okay, we'll be discussing about this in the third module in much more detail. Okay, so for now let's move on to the next point, which is multi-threading. This means that a single program can be run in different ways. Okay, so that's called as multi-threading. And architecture neutral means the same program can be run on many machines and platforms, because there is no strict architecture for each machine. The structure of the program is general and can be run on any machine. Okay, so that's architecture neutral. And interpreted means it performs the in-time compilation. High performance because it uses bytecode, which performs the execution very fast. And distributed means it can be used on any platform. And dynamic means it adapts to the evolving environment, because in Java we use packages, so whenever a user's need is changed, we can add a new feature in the package so that the users use the program more efficiently. Okay, so that's about the dynamic feature of the Java. And these are the 11 best buzzwords. Let's move on to the next topic, which is object oriented programming. In this we have the 4 topics, which are abstraction, encapsulation, polymorphism, and inheritance. Let's quickly discuss what it is. In abstraction, it means hiding the background details from the user, so whenever you run a program, you won't be able to know how the program is written, right? So that's nothing but abstraction. Talking about the real life example, see a car. If you see from outside, it will be looking like it's moving, stopping, accelerate and all, but if you look from inside, you will have the seat, engine, brake and windows. And if you go more deeper, you will have the micro objects and other subunits. Okay, so if there's a problem with a brake, you need not know about the micro objects and the subunits. You can just come to this level and solve the issues. Okay, so that's what abstraction helps in. If all these things were visible at the same time, it will be very hard to focus on what actually needs to be solved, because other things will also be visible. So abstraction helps in solving complex problems by dividing the whole problem into submodules and solving the exact problem where it is. Okay, so that's about abstraction. Coming to encapsulation, it means wrapping up of data and function to a single unit. Means inside the class you can have the data here and the functions here, so the data members are not accessible from the outside world, and that provides the security of the data. And the functions which are present inside the class, those functions can only access the data members of the same class. Okay, so that's about the encapsulation. Inheritance means if you have a parent class here and the features are being inherited by the subclasses. Suppose that there's a car here which can just move. Okay, so only one feature it has. So if you want to create a new class without changing the old class, what you can do, inherit the same class and add the feature of like changing the direction. Okay, so you'll have a new class here which is the subclass of the base class. Okay, so that's called as inheritance. And in this you can inherit the main class and add new features to the subclasses. Okay, and coming to the last one, which is polymorphism, it means the usage of the same message differently in different contexts is known as polymorphism. Okay, in polymorphism you have the same message being used differently in different contexts. If you add 2 numbers, you will get the result as 2, while if you add 2 characters, you will get a string AB. Okay, so usage of the same message differently in different contexts is nothing but polymorphism. In Java you can use polymorphism for function overloading. So I have the same function here, add. Here also add is there and int a is there. Okay, so system dot out dot print a, so a will be printed if I call this function with 1 parameter. If I call the function with 2 parameters a and b, and that time the system will print a plus b. Okay, that's the sum which is getting printed here. Okay, before moving on to the main program, let's discuss some basic concepts about the Java, which is the class. Class is nothing but a blueprint. Suppose that here you have the car's blueprint, which will include the windows and other parts of the car, and by using this blueprint, if you create a car, that's nothing but the object. Okay, and methods means the functions which the object performs. Like in this case, the functions are move, stop and horn and the other functions, and the data members are nothing but the objects what the whole object is made up of. Okay, so the object is made up of door, wheel and window, engine, etc. Okay, so those are the data members of the object. Okay. the first Java program. In this program you will have to create a class. See, in the C++ and C we are not creating a class, just we are writing void main directly, right? But in this we have to create a class for each and everything, even for the void main. Okay, why? Because when we create a class here for the void main, at that time the compiler uses this class to create an object out of it. So the object will have a void main function here, and then by executing this object the void main function will be run. Okay, so that's why we are creating a class to run the program inside the compiler. Okay, so first we have to write this statement, public class, then your class name, and inside that the function will be public static void main. Since void main is a function, we will have the arguments as string, an array of arguments. Okay, now after that you have to print out the statement which you have to print out in the between the braces and the double quotes. Print out the text which you want to print. Okay, now let's see each of these one by one. What do this mean? Each of these keyword has a specific meaning. Public means it's an specifier, means it should be visible to all the program, the whole program. This class should be visible, so we are using public. And class is the keyword for declaring a class, and the name of the class will be defined here. Okay, that's the first statement. Okay, that's the first statement. Second one is public static void main. Now see here, public is the specifier, static is used for not changing the value for the whole program. When we use static, it will be having just one copy of the void main. We need not create many copies of the void main for each individual object. Okay, so that the same whatever changes we make, it will be reflected in all the objects. That's why we use static void main. And then the argument is string args. What does it do? It basically stores the numbers here, or the whatever value we enter here, that will be stored in this array. Okay, so what is the use of storing this in the array? Actually the use is not for storing, it's for the JVM, which is Java virtual machine, to identify which is the main function. Remember, Java looks for the main method with a string type array as a parameter. So among many functions here, how will the JVM know which is the main function? It will only know the main function by checking for the arguments. Wherever it gets the argument string args, at that time it identifies the function as main function, and that will be run first. Okay, then only rest of the functions will be run. Okay, for that purpose only we are using this. And this is all about the first Java program. These two things consider as a header files which we include in the C and C++, and the main thing for the output is this one, and between the braces and the double quotes you can print it. Okay, and you can use this same statement for printing other values also. Okay, coming to data types, sometimes we need to store numbers, sometimes we need to store the decimal values, sometimes we need to store the alphabets. So we need different types of data types. Okay, so there are total 8 primitive data types. Let's discuss one by one with examples. First one is boolean. It stores either true or false. Okay, means this will be stored true or false. Okay, this will be stored in the boolean. It just requires one bit to store either true or false. Next one is char. Char stores the alphabets, means A, B, or even it can store one within the single quotes. It will be considered as a character. Next is byte. Byte stores a number which is of 1 byte. Short stores a number which is not exceeding 2 bytes, and int not exceeding 4 bytes, and long not exceeding 8 bytes. So it is used to store the range of numbers ranging from negative values to positive values. Okay, it's a large domain and it can store a variety of numbers. Okay, and if you want to store the decimal numbers, at that time you have to use either float or double. If you have to store like 7.58, at that time you can use float. If you have to store a bigger decimal numbers like 10 or 12 floating digits, at that time you have to use double. It can store 8 byte decimal numbers. Okay, so let's see for each of these an example. Suppose that I have to create a boolean variable. I will use this syntax, boolean, then the name you have to give here, then either store true or false, all within small caps. Okay, then system.out.print a. When I print a, what output I'll get as true. If I store here as false, then I print a, that time I'll get false here. Okay, that's for boolean. Coming to character, it can store a single character. Create a variable and store any character, then print out that, you'll get the output over here. Okay, if you have to store the numbers not exceeding 1 byte, you can store using byte. If you have to store the numbers using not exceeding 2 bytes, you can store using short, or else you can go for int a is equal to 75. Or if you want to store bigger numbers which are of 8 bytes, at that time you can go for long. Okay, If you have to store the decimal numbers, go for float x is equal to 7.5, then print out x, it will be output as 7.5. If you have to store bigger decimal numbers, at that time go for double x is equal to this number, and when you print out this number, you will get the output here. Okay, this for the primitive data types. By using these data types, you can create further data types like arrays and classes, objects and linked list and stacks and all. Okay, so we'll be looking at that in upcoming topics. Okay, coming to literals, it's nothing but the constant that do not change the value in the program. Okay, so if you declare a literal like 1.2, the whole program will use the value as 1.2, and if you try to change, it will output an error. Okay, literal means constants. Okay, and coming to string, see in C and C++, if you have to store a sentence, what we used to do, we used to create an array of characters with each character stored at a particular place, and then using a for loop will print each of these letters. But that's removed in Java. We can directly create a variable called string of the type string, wherein you can store the whole sentence inside the variable, and if you try to print this variable, you'll get the output as the same sentence which is stored. Okay, coming to variables, it's the opposite of the literal. Literal means the value cannot be changed throughout the program, but in variable you can declare as well as change the values. Okay, see here how to declare a variable. You'll use the data type and the variable name, and inside this variable you can store the value which you want. That's known as initialization. So I stored here 10, and there are three types of variables. First one is local, second is instance, and the third one is static. Let's understand each of these by using an example. See here, here is a class ABC, and I have the static variable and instance variable and local variable. What's a static variable? The variable having the word static behind it, that's known as static variable. Its value is copied, means its value is reflected across all the changes made in the program, but in the instance variable that value is not reflected here. Okay, so that's the difference between static and instance variable. And coming to local variable, if you have initialized a function inside the class, and inside that if you declare any variable, that's known as local variable. See here, the instance variable is outside any of the function, it's directly created after the class, right? So it's instance variable, whereas if you declare any variable inside a function defined, that's known as local variable, and this variable can be accessed only in between the opening and closing braces of the function. Okay, so that's known as local variable. And coming to dynamic initialization, the initialization of the variable happens during the runtime. Suppose that I have two variables A and B having the value 10 and 5. Now I don't initialize the value of int C unless the program runs and this particular code is run, means A into B, which is 10 into 5, 50. After that gets calculated during runtime, then the C's value will be initialized. That's known as dynamic initialization. Okay, opposite of this is the previous one which I declared here during the program only. Okay, before the program runs, the value of A is determined, so that's known as non-dynamic. And if the value is determined during the runtime of the program, that's called as dynamic initialization. Okay, coming to scope and lifetime of variables, the variables can be accessed only in the block in which it is declared. To make it more clear, consider an example here. See, this is the class scope. Okay, and this is the void mains opening braces. Okay, now I have declared a variable called x of the type int inside this block. Okay, inside the void main. Where can I access x from? See, this is the opening braces for the void main, and this is the closing braces for the void main. So x can be accessed anywhere within this scope. Okay, this is the scope for x. Now suppose that I declare a variable y within the block opening braces and closing braces, so I can access y within this block. If I try to access y here or edit the value of y here, it will give me an error because the scope of the y is over after this closing braces. Okay, but I can access x still here because x is within its scope. Okay, void main is not over here. See here, void main is not over here, void main is over here. If I try to access x after this point, then it will show me an error. Okay, but I can access x before this point, and that's the scope of x. Okay, so that's it. Scope means the block in which the variable is declared, in that block only it can be accessed. Okay, what is type conversion and casting? See, before I told you, right, byte is of 1 byte, it stores 1 byte, and short stores 2 byte, then int, then long, right? It's increasing order. Suppose that I have a variable here long. Okay, long L, and I have the integer I and if I equate this by using an assignment operator, L is equal to I, at that time int should be converted to long. That's happened automatically from the smaller data type to the bigger data type. Okay, that's known as implicit conversion. And if you have to convert a bigger data type into smaller data type, at that time we have to do from our own self. Okay, that's known as explicit conversion. Let's see an example here. Double D. Okay, D is of the type double, having the value 100.4. Now if I create a variable called long L and I want to assign the value of double to the L, at that time what I will be doing is I will be mentioning it should be of the type long. Integer part of the variable, which is 100, that will be stored in L. Okay, because long is used for storing integers only. Okay, so at that time 100 will be stored. When I write this code, int of L, at that time if L has the value like 10,000, at that time if I have to store the integer part of L inside the integer I. Okay, because integer I can store smaller values, so whatever the smaller value is possible to be stored inside I, that will be converted by this code and that will be stored in I. Okay, if the variable is having the greater data type, to convert it into smaller data type, we will be mentioning which data type we want, at that time that will be converted and that will be stored in the variable. Okay, so to recap, implicit conversion happens from smaller variable to greater variable, and explicit conversion means greater variable to smaller variable. Okay, coming to arrays, it's the same thing as we have studied in C++, but only the syntax will differ. Okay, for 1D array you have to use this syntax. For both 2D also it is same, just a slight difference. In this you have to mention the type of the variable, opening and closing square braces to indicate the program that it's an array, and the name of the array, then use the keyword new, and then the size of the array. Okay, this will create an array of 12 spaces wherein you can store the values like a month of 0 as whatever value you want to store. And for printing you have to use system.out.println, and whichever element you want to print, mention here that number and that will be the output. Same thing for the 2D array also, you have to use two square braces, and here you have to mention the size, and the initialization and the output are the same as the previous one. Okay, coming to operators in Java, what's an operator? If I write 1 plus 1 is equal to 2, at that time we have two operators here. First one is plus and second is equal to. So there are many types like greater than or not equal to. So there are many types of operators which are classified into 6 groups, which are the following. So we'll be discussing each one of the group by using an example. Okay, let's talk about the first one, which is arithmetic operators. In arithmetic operators, the operators are used to perform addition, subtraction, multiplication, division, and the modulus operator, which is used to find the remainder. Let's see how it works. In the void main I have defined two variables, a as 10 and b as 5. If I output a plus b, it will become 15. If I output a minus b, it will be 5. Like that we can perform all the arithmetic operations by using the operators plus, minus, into, divide, and modulus. What does modulus do? If I write a modulus 10, a modulus b, at that time it will be 10 modulus 5, which will give me 0, because the modulus of a and b is nothing but the remainder which I get when I divide 10 by 5. If I write 13 modulus 5, at that time the remainder will be 3, because when I divide 13 by 5, the remainder is 3. So modulus operator gives me the remainder. Okay, coming to relational operators, we have 6 relational operators. We are using these operators in if loop. Okay, suppose that I have a value here, if age is greater than 18, then some code here like eligible to vote. Okay, so I'm using this operator here, right? So by using this operator I can check if the age is greater than 18 or not. Okay, so that's the thing here. We have many operators here. Equal to, at that time if a is equal to b, see this is different than equal to. Okay, if I write a as 10, okay, a is equal to 10, at that time 10's value will be stored in a. But if I write if a equal to 10, like that if I write, I am checking if the value of a is 10 or not. Okay, so double equal to is used for checking and single equal to is used for storing. Okay, and like that we have many types. This is known as not equal to, means if a is not equal to b, then perform the function which is given here, or if a is greater than b, less than b, greater than or equal to, less than or equal to. These are for checking the conditions before performing the operation given in the code. Okay, Coming to bitwise operators, we already know the functions of AND, OR and XOR. AND will be 1 only when both are 1, okay, both the bits are 1, and OR will be 0 only when both are 0, and XOR will be 1 only when only when either is 1. If both are 1 or both are 0, at that time XOR will be 0. Okay, so by using this we can perform the operations of AND, OR and XOR bitwise. Means if I have the variable A as 1110 and B as 1010, if I perform the AND operation between A and B, at that time AND will be performed between each of the bit, and the answer is calculated. 0 and 0 is 0, 1 and 1 is 1, 1 and 0 is 0, 1 and 1 is 1. So this is the answer for bitwise A and B. Okay, similarly we can do for the OR also. So each of these bit will be ORed and the answer will be calculated, and same for the XOR also. Okay, so these are the symbols for each of these. Under the same topic we have shift operators also. That means we have to multiply or divide by 2, okay, or powers of 2. We have two types. First one is left shift and second is right shift. This is used for multiplication. Remember, left shift is used for multiplication and this is used for division. Right shift is used for division. Now see here, if I use this operator here, 10 less than 2, at that time what answer I will get is 10 into 2 square. If I write 10 less than 3, at that time I will get the answer 10 into 2 cube. So whatever number I mention here, that number's cube with 2 will be multiplied with the number I give here. Okay, so if I write here 10 less than 5, I'll get 10 into 2 power 5. Okay, so this for the left shift, and the right shift does the same thing but it divides. Okay, if I write here 2, it will be 10 divided by 2 square. If I write here 3, it will be 10 divided by 2 cube. Okay, so here it should be 3 actually, so it will be 10 divided by 2 cube. Coming to the next one, which is unsigned shift operator. In this it's same as the previous one, but it's slightly different because in this operator we do not extend the sign. Okay, so let's see what it is by an example. See here, suppose that int x is there, and I wrote the code 13 and the unsigned shift operator, which is right and 1. Okay, what does this code do? See here, 13 in the binary it is written as, if you don't consider the sign extension, it will be 1101, right? If I write 13 unsigned right shift operator and 1, at that time 10 will be inserted from here. So last bit will be cut off and 10 will be inserted here, so it will become 0 and all these bits, and excluding the last bit it will be 110. Okay, so that's the answer, which is 6 here. It will be performed by unsigned operator. Okay, we are inserting the value from the left. Okay, that's unsigned right operand. Its significance is seen when we use for negative values, because for positive values it's same as the right shift operator. Okay, but when we use for negative numbers it's different, because in negative numbers we have the sign extension as 1. Okay, so when we use -8 unsigned shift operator 2, at that time 2 zeros will be inserted from here. Okay, when we insert 2 zeros from here, it's no more a negative number, it became a positive number, because the only differentiating factor between a negative and the positive binary is the first bit which is placed. It should be 1 for negative numbers. The first bit is seen, it is 0, so it's a positive number. Okay, so in this case the number is deferred. It becomes a very large number because we have a great number of bits to be considered after the positive one. Okay, coming to logical operators, we have 3 types: AND, OR and NOT. So what does AND do? If you have to execute a code which requires both A and B to be true, at that time we use this operator. Okay, coming to the second one, which is OR. If either the value of A or B is true, at that time the code should be executed. At that time we will use OR. And NOT means if the negated value of A should be true for the execution of the code here, at that time we will use NOT operator. Okay, assignment operator means is equal to, means if you have to assign some value to the variable, we will use this operator. And if you have to write m plus m is equal to, if you have to write m is equal to m plus 10, it's a we can write using a short key, which is m plus is equal to 10. That will perform the same operation. Same thing we can do for the other operations also. So all these operators come under assignment operators. Okay. increment and decrement operator is nothing but plus plus and minus minus. Okay, plus plus means it increases the value of the operand by 1 and decrements the value by 1 in the minus minus operator. Okay, so let's see an example. A, I have defined A as 10 and B as 20. Okay, so if I use A plus plus, A will become 11, and similarly B plus plus, by using B plus plus, B's value will become 21. A minus minus will make A as 9 and B minus minus will make B's value as 19. Okay, so that's used for incrementing and decrementing the values. Coming to Java ternary operator, here you will have 3 expressions, and based on the truth value of this expression, either this one or this one will be executed. Okay, let's see an example here. In the main function, I have int a is equal to 2, so a's value is 2, and int b is equal to 5, so b's value is 5. And here I have written int min, so the min's value will depend on the statement a is less than b. Is a less than b? Yes. 2 is less than 5, so it's true. If it's true, min will be equal to a. If a was greater than b, min will be equal to b. Okay, so basically it depends on this statement whether this will be selected or this will be selected. In case this statement is true, this will be selected, else this will be selected. Okay, so that's the Java ternary operator. The next one is control statements, means suppose that there is a block of code here. If you want to execute this block of code or not depends on a particular condition. At that time you use control statements. Okay, so first one is if else. Suppose that int age is defined as 20, so the value of age is 20, and by using an if else we can print either this or this. Okay, if age is greater than 18, system.out.print eligible to vote, or if it's less than 18, system.out.print not eligible to vote. Okay, so by using if else, either this one or this one will be executed. Okay, second one is nested if. In nested if we have I have defined 3 variables a, b and c with the values 10, 20 and 30. What happens in nested if is, if I want to find the greatest of these 3 numbers, what I will do, I'll write a if statement. If a is greater than b, if it's true, then execute this statement, and check if a is greater than c also. If both are true, means if a is greater than b also, if a is greater than c also, print a is the greatest. Else if a is not greater than c, then the comparison should be made between b and c. If b is greater than c, at that time b will be the greatest, else c is the greatest. Okay, so if we have a kind of question in which we have to check the values depending on the previous values, so we can use nested if loop. Okay, the next one is if else if ladder. In this if I have to execute a statement which depends on the multiple conditions, suppose that int marks is defined as 55, so first I have to start from if marks is greater than 90. If it's true, print out distinction. Else if it's greater than 60, print out average. Else print out pass, or else print out fail. Okay, so in this case I have to check each statement one by one. Okay, so in this particular scenario I can use if else if ladder. Okay, coming to switch statements, I have defined day as a variable which is having the value 5. Day is equal to 5, and I will be switching the variable value with the following cases. Okay, so what happens is the day's value will be compared with each case 1, 2, 3, 4, 5, 6 or 7. So in which case it matches, that statement will be executed. So Thursday will be printed since day's value is 5, and it will be breaking out of the switch statement. See, if I don't include this statement break, at that time the rest of the statements will also be executed. Okay, and in case the value of day is 8, suppose it won't match any of the cases, at that time default value will be printed, means this will be printed system.out.print enter a valid choice. Okay, that was all about the control statements. This is about the iteration statement, in which if you have to execute a particular statement multiple times based on a condition. See here, for example, while loop. In while loop, if I have to print out 0, 1, 2, 3, 4 and 5, what I can do is I can use a while loop starting from num is equal to 0. While num is less than or equal to 5, print out the value of num. So for each iteration 0 will be printed, then 1, then 2. By using the increment operator, num's value will be increasing till it reaches 5, and after that num's value will be becoming 6 and it will not execute here. Okay, so till from 0 to 5 it will be printed. The second one is do while. Do while means the particular statements will be executed at least once, and it does not matter if the condition is true or not, because first it will be executed, then the condition will be checked. Okay, suppose that I have to display to a customer the menu. like in hotel and all, like if you have to place the order or order a drink or such things, okay, or else at the last one cancel the order. So in the same case, in the programming what we can do is we can use the do statement for having the menu, and if else if statement, switch statement, if else statement, or exit. At that time the user will choose the statement, the number will be chosen by the user that I have to store in the choice, and then I will be checking at last while choice is not equal to 4. If choice is 4, it means exit the loop. The next one is a for loop. By using a for loop, we can print a statement multiple times, like if you have to print the values of numbers from 0 to 9, you can use this statement. For I is equal to 0 till I is less than 10, print the value of I, okay. For each is a specific one, which is specific type, which is not present in C or C++. So in this one what we do is, see, suppose that there is a array of numbers which is having the numbers from 1 to 10. At that time I can calculate the sum of the numbers by using for each statement. So the syntax is as follows: for int x colon num, and inside this I have the statement to be executed, okay. So what happens is x will access each value of the num array. So firstly x will have 1, then after this statement gets over, x will have 2, then x will have 3, then x will have 4. So each iteration x will be accessing the values of num, okay, and it will be calculating the sum, okay. So it's actually faster than the for loop, which is having the increment operation here and the comparison operation here, okay. So it's much faster than the previous one, and it's widely used in Java. See here, int x colon num is actually the following operation. X will be accessing each value, and then it will be passing on to the next value, okay, till the last value. And you can edit this code here also, like if you want to display all these values, you can write here system.out.println x value, okay. So at that time all the values from 1 to 10 will be displayed, okay. The next one is jump statements. It means if you have to skip a part of the program, or you have to continue from a different part of the program, then you will be using jump statements. You have to, we have two types. First one is break. Break you have already seen in the for loop. If I write the statement if I is equal to 5, break. At that that means this loop will run till I is equal to 5. After that it will break. It will not go for 6, okay. So break is used to terminate the program, okay. And the second one is continue. Continue means, observe this code here. I have a for loop which runs from I is equal to 1 to I is equal to 10. Now what I have the condition here, if I percentage 2 is equal to 0. What does I percentage 2 mean? Initially the value of I is 1, so 1 percentage 2 is nothing but when I divide 1 by 2, at that time I will get the value remainder as 1. So whenever I get the value 1 or a different value, and when I divide by 2, that means it's an odd number. Suppose that I have 4 here and it divided by 2, at that time I will get the value here as 0, okay. That means it's even. So by using the modulus operator we can see if the number is odd or even, okay. Now what we have to do, if this is true, means if the i's value is even, at that time continue. Continue means the rest of the statements will not be executed and it will start the iteration from here, okay. So what happens is only the odd values will be printed, because whenever the i's value is even, at that time it will execute continue, which will start the iteration from here without printing the following statement, okay. So only odd values will be printed, 1, 3, 5, 7 and 9, okay. Let's summarize the difference between break and continue. Break statement is used to terminate the loop, and continue statement is used to skip the current iteration, okay. By using continue you can skip the current iteration, okay, but it will not end the loop, okay. The second difference is there are two types. First one is unlabeled and second one is labeled. Unlabeled means the following code is unlabeled because there are no labels here, just the break and continue statements. And what about labeled? Let's see by using an example. For the break statement, I have a class break here which is having void main and no other functions, and I have one data member which is boolean t. So t will store the value true here, okay. I have defined t to be true. Now I have defined some blocks of codes here which is having names. This is nothing but labels. So this is called the first block and second block and third block. So let's see the scope of the blocks. The third block is defined here, okay. This is the third block, second block is this, and the first block is this, okay. So these are the blocks. Let's see how to let's see what the labeled break statement means. Firstly, the statement will be printed system.out.print before break. So in the output we will see before break, and after that this will be checked. If t, what's the value of t I have defined? True. So this will be executed and break second will be executed. In this, break second means break the second loop. See here, what's the second loop? Second loop is this one. Break the second loop means come out of this loop. So these things won't be executed, this one and this one. It will start the execution from here, okay, from the first one, okay. So this will be printed, this is after second block. So what happened here is, when I used break second, at that time what block I have defined as second, that one will not be executed, okay. So if I had written break third, at that time this particular code will not be executed, but the remaining one which is present in second block, that will be executed, okay. This one will be executed, but since I have written here break second, this won't be executed, and only the last statement, which is this is after second block, will be output. See here, the output will be before the break and this is after second, okay. So this one and this one, okay, that will be the output. To understand the labeled continue, it's a bit tricky, so observe carefully. Firstly, I have written outer, this is the label for continue, and I have defined a for loop inside which I have another for loop of j, okay. So what happens is, if j is greater than I, then this particular code should be executed, okay. So since j is not greater than I, means I is 0 and j is 0, this won't be executed, and this will be print out that I into j. What is I into j? I's and both j's value is 0, so this will be printed as 0 in the output, okay. See here, it's 0, okay. Then j's value will be incremented as 1. Then j is greater than I, yes, it's true, and what will be printed? Continue outer. What is continue outer? What will happen is, the whole j loop will be skipped, okay. This is the j loop, this will not be executed, and the program will continue from outer, okay. That's the use of continue statement. It will not terminate the program, but it will start the iteration from wherever label we mention, okay. So it will start from here, I will become 1, and the same thing will repeat, okay. Coming to return statement, suppose that I have defined a function here as add two numbers, and in the void main function I call this statement, okay. Then this function will be executed and the sum will be calculated here, and I want this sum back in the main function. So I will use a return statement as return sum, okay. So it will return the sum which is calculated in this function to the main program. That's one use of the return statement. And the second one is the return statement written in the return statement for stopping the execution of the program. So it's usually written at the end of the program, but if you want to stop the program at the middle of its execution, at that time also it can be done by using the return statement based on a condition. See here, in this main function I have written boolean t and defined t to be true. Then I have printed before the return, so this will be printed, and then if will be checked. If t is true, this will be executed here, return will be called, and the program will stop executing from here, okay. So this won't be printed, this won't execute, this won't be printed, rather the program execution will stop, and whatever the output we see is only before the return, okay.